we're solving problem 23 from the 2018 F equals MA exam B. Two particles with mass m1 and m2 are connected by a massless rigid rod of length L and placed on a horizontal frictionless table. At time t equals 0, the first mass receives an impulse perpendicular to the rod, giving it speed v. At the moment the second mass is at rest, the next time the second mass is at rest is blank. So then we have two diagrams here. The first one's just a normal diagram, and the second one is when we go into the CM frame. Now here we display the motions. So we have first of all v sub cm in this case is equal to m1v over m1 plus m2. Therefore we can start listing out other things. So let's just list out velocity 1. If we have v1, this is equal to m2 times v over m1 plus m2. And then we have the distance from the point to L, which is just equal to m2 L over m1 plus m2. Now that we have these properties, what this basically means is that we know it's going in oscillations, and we know that we can also write out t is equal to 2 pi d over v1. So we can also see from these equations that eventually after one oscillation, the speed will be turned back to its original velocity, so therefore it will be at rest after one oscillation. So the time period is 2 pi d over v1, or just 2 pi L over v when you plug that one in. So then this is our answer. And this corresponds to answer choice A on the test, and we are done.